So as a one-liner, that's what we want to achieve, to design and develop modern, secure web apps. The word modern there doesn't really mean anything. I have to expand on that. The other thing we can take from that statement is obviously very much heavily practical based. So we will be doing a lot of development. By design there, I'm more talking about the design of your and structure of your code base, i.e. your JavaScript code base, not so much UI design. I'm not going to get into any kind of CSS stuff. I'm assuming people have those skills from earlier modules, in particular website development, which people would have done quite a while back now, admittedly, but you may need to refresh your CSS skills and obviously HTML. So I'm going to give a context for this module, and that's really the whole area of web apps. Then I'll talk about the module in particular, what we will be looking at in terms of what tools and platforms we're going to use. The last item there I obviously don't have to cover because we already know what installations are required. At the very end, I'll say a little bit about the assessment structure because I haven't spoken about that so far. Now, in the one-liner there, I use the word modern web apps, and this is my kind of representation of how modern web apps are architected. So the way these modern web apps work, when the user kind of visits the web app or website, it's this part of the architecture that is active initially. There's an ordinary web server, and the purpose of that web server is to supply the core assets of the web app, these being the assets. Now, there is actually very, very little HTML. In fact, there is only one HTML file, and it doesn't have any body to it. It's essentially a shell or a skeleton web page. There is a heck of a lot of JavaScript stuff sent down, and the amount of CSS depends on how much styling is being done. So the really important part is the JavaScript. And when these assets arrive in the browser, the JavaScript kicks in straight away, and it essentially constructs the view of the web page that the user sees. It does it dynamically in the browser. And then perhaps as well, what it might do, the JavaScript that runs initially, is it may actually send the request down to a web API. We've got a kind of a sense of what a web API is from the random user generator the last day. The web API presumably is connected to some sort of database, and it will return some data. And that data is used by the JavaScript to stitch into the web page that is presented to the user. And then the user behaves in the normal way. They interact with whatever is presented to them. By that, I mean, they click on things, they select drop-down menus, enter something to a text box, etc., etc. And based on that interaction, the JavaScript is going to be running behind the scenes and reacting to what the user has done. So some of those interactions by the user may cause the JavaScript to actually change what's being displayed on the browser. Or it may cause it to make another request down to the web API to get some more data, or ask the web API to do some sort of computation and return back the result. In either case, the web API comes back with some more data. The JavaScript takes that data and again, kind of stitches it into what the user sees. And that continues, that kind of sequence kind of continues. But by that, I mean, user interacts, JavaScript responds to that interaction, perhaps talks to the web API, but will always change what is being presented to the user. So it's the JavaScript that's actually constructing what the user sees. The top part here has no role any longer. It's only involved in the initial uploading of the assets to the browser, and then it's really out of the picture. So that's how modern web apps are structured from an architecture point of view. This is just a representation of the kind of communication flow that I was talking my way through there. So on the left, we have the browser, talks to the web server on the extreme right, just to get the initial assets. And from there on, the web browser is interacting with the web API, either sending GET requests for data. Possibly it actually may also send a POST request down to the web API. If the user has to fill out some sort of form and submit it, that submission triggers a POST request. The POST plus the data is sent down to the web API, which presumably stores it in some sort of database or whatever. So that's how the communication flows. In these modern web apps here, I'm just showing you what I'm calling the role of the different subsystems. Now, the subsystems in this, it's a distributed system really, in a way. And there's two parts to this distributed system. There's the orange box, which is representing my browser. And that actually, there's a lot of activity going on there. And in particular, the web browser, by virtue of the JavaScript, is responsible for rendering and navigation. By rendering, I mean it actually constructs what the user sees on the screen. And by navigation, I mean as the user interacts with the browser, they will see the address bar in the browser changing. And that change in the address bar will again trigger the JavaScript to do certain things. So the impression that the user gets, if they are actually watching the URL address bar of the browser, which, okay, most people don't, but you guys as technical people, you would notice that the URL in the browser is changing. So the impression is that we're kind of jumping from one page to another page, but in fact, that's not really happening behind the scenes. The green box in the middle then, that's my web API, and that's where all the kind of heavy lifting goes on in terms of any algorithms that are relevant to this particular web app, any business logic, any data processing. And then on the extreme right, we have some sort of database. So that's how modern web apps look and feel. Traditional web apps, I'm just using these terms now. They're not very technical terms. There is technical terms, which I'll mention at the end to distinguish one from the other, but traditional web apps would have been the type of web app that you would have developed in Web App Development 1, that module. I'm assuming everybody has done that module. You've done it at different stages, but if you can think back to when you are doing it, this is how those web apps looked in terms of the architecture. There was only one server, which is, sorry. So the way they worked is the user visited the particular web app. That caused the browser to send the request down to this web app server. And it perhaps consulted with the database, but critically, what it did was it actually constructed the web page, and it sends the web page plus any CSS back to the browser. Very little JavaScript, if any, involved in these types of web apps. The browser receives the HTML and CSS and displays it. Every subsequent interaction by the user with the browser will immediately cause the browser to send a request down to the web app server. It responds perhaps by consulting the database, but it will actually build the updated web page down here and send the complete web page back to the browser again. So it's doing all the work. In the previous architecture, as I said, the browser was actually constructing the web page, whereas now the server is doing it. From a subsystem roles perspective, really, you can see the orange box there I've left as empty. And what we often say is that it's a dumb client. It really doesn't do anything. It just receives the HTML and displays it. User interacts with the page, and immediately the browser consults with the web server, again, the application web server, again, to produce the updated web page for the browser to render. So you can see in the green box in the middle, it is now responsible for rendering. Rendering means constructing the web page, as well as all the other stuff, as well as the algorithmic stuff, the business logic, the data processing. From the user's perspective, you cannot tell really as an ordinary user, am I interacting with a modern web app or a traditional web app? You can't tell. They behave the exact same way. The URL in the browser appears the same. It's changing as the user clicks on things, but there's no way of knowing from the user's perspective which type of architecture is actually behind the scenes. This is the communication flow. And again, I've already kind of explained it, I hope. But we're only interested in the modern option there. And I'm kind of very loosely kind of detailing, outlining here the kind of evolution of this type of web app. And they've been around for quite a while. So we're going back to 2004 when they really first came on the scene. The original YouTube was this type of web app. Gmail was as well, I think. But a lot has changed really since 2004. And I'm kind of giving the chronological order in which things kind of happened. So the modern web app that you might have been developing back in 2004, there wasn't really much best practice in terms of how you structured your JavaScript code. There was a heck of a lot of JavaScript code, so there was a lot of code bloat. And as a result of code bloat, the maintainability of the JavaScript code was very low, very poor. There was also an issue with browser inconsistency. So your JavaScript might work properly in one browser, but not in another browser. I'm also saying here that they lacked addressability. When I was talking about the modern web app there, and indeed the traditional one, I was saying that the URL in the browser changes as the user interacted with it. But in fact, in the very first iteration of these modern web apps, that characteristic of the changing URL in the browser, that's referred to as addressability. It goes back to the very early days of the web when we just had static websites and hyperlinks. And every time we clicked on a hyperlink, that changed the URL in the browser and the page changed as well. And so the idea was that each web page on the World Wide Web had its own unique URL, or it had its own unique address. That's this addressability characteristic. But that characteristic didn't actually exist in the early forms of these modern web apps. The URL just remained static. The view was changing okay, but the URL remained static. And that was a real weakness. So that was kind of the first generation. Then this revolutionary library called jQuery came on the scene in 2006. And jQuery kind of solved these kind of problems up here. It significantly reduced the amount of JavaScript code that you had to write. It put a little bit of structure on it. It solved the browser inconsistency problem. It didn't solve the addressability problem though. The next evolution, which is number 3 down the bottom there, is what are called single page app frameworks. And that's kind of where we are today. So we will be looking at a particular single page app framework. And what they did was they significantly improved how you structured your JavaScript code. They also solved the addressability problem. And so that's where we kind of are now. Now, to give you a tangible example of a web app, we're actually going to develop this web app in the labs starting from maybe next week, but certainly the week after. And what this web app does is it's for movie enthusiasts, Maria. So this is the home page, and what I've got here is a list of various movies. Now, all this movie detail has been pulled from a web API called the TMDB API. I'm just mentioning there. And if you look at the URL now, I'm running the web server from localhost, but obviously you would deploy it in real world. But I can click on one of these movies, and if you watch the URL address, it's going to change. Now, when I clicked on the image, a request went back to the web API to get some more details on that particular movie. And so I'm displaying the movie here, details here. I've got a button down here, which if I click, again, the URL is going to change. And when I click this, I'm getting some reviews written on that movie, again, pulled from the web API. If I click on this, I can get the full review. Again, the URL has changed in the browser, and the full review has been pulled from the web API. If I go back to my home page, now I can do things like filtering, which won't cause the URL to change. I can also I can select certain movies as being my favorites, and they get removed from this page, but added to another page. If I go over to this hyperlink here. Okay, so I'm navigating around the place. I can click on this now and I can write my own review. And all the time, as I said, the URL was changing, but in fact, all that was happening was, okay, the physical URL was changing, but the JavaScript behind the scenes was always just reconstructing the UI for us, as well as communicating with the TMDB API. There, in terms of the actual code, you can take my word for it, right? If we look down through the code base, we would only find one actual HTML file, which is this one here. And if you look at it, just glance at it, there's actually no body to the web page at all. And that's the only HTML that exists. All of the action is inside in the SRC folder, which is where all my JavaScript is. So that's what we will be doing in the labs later on. So that's kind of the context, the modern versus the traditional. Now, there are technical names for them, though, really. The modern one is referred to as client-side rendering web apps, as in the client, the browser, is actually responsible for rendering the UI. The traditional ones are classified as server-side rendering web apps, as in it's the server that's responsible for generating the UI. So in this module, this is back to our modern web architecture. And there's really two parts to it. In the first part of this module, up to about week 6 or 7, we're going to be focusing on the kind of client side and developing the client side. And we will be using a single page app framework called React. By the way, that term there, single page app, where that kind of comes from is the fact that there is only a single HTML file within your code base, and I showed you it there a moment ago, the index.html. There's only a single HTML file, yet there are multiple views in the app. So now that's where the term single page kind of comes from. So we're going to be using a single page app framework called React. And in very simple terms, all React is a JavaScript library for building browser-based UIs. On the other side, then, on the kind of web API side, which you will be developing as well in the second half-ish, there we will be using two technologies, Node and Express, again, both JavaScript-based. And from a database point of view, we will probably be using MongoDB. Although, time constraints may not allow us to get as far back as the database. We're not really too sure yet whether we'll get that far. And so if you know anything about Node and Express, you will know that they are JavaScript-oriented technologies. And in fact, MongoDB is kind of a JavaScript type non-relational database. So from end to end, it's kind of JavaScript all the way. That makes life just a little bit easier on you, so that you don't have to juggle more than one language. We could have done the web, we would have to do the client side in JavaScript, obviously, although that is changing too, if you know anything about WebAssembly. But the server side, the web API, we could have used any language there. Java, Ruby, Python would be very popular, but you'd have to juggle two languages, and that's really an unnecessary complication, we felt anyway. And thirdly, then the database, which is really a database of JavaScript objects in a way, called documents. So the learning curve isn't as steep as it could be if we pick different technologies. So that's the modules focus. Software installation, then I don't have to talk about. Before I go on, maybe I should just stop for a second. If there are any questions. No.
Are all our assignments, are they going to be the same? Like, is it all based on building that movie kind of?
Well, the labs, yes. That's actually my next slide here, right? We know that. We know you will need a GitHub. I am telling you here as well, just you can change your, go into the settings side of your GitHub and just make sure that it's your proper name as recorded on Moodle for here, because that makes life just a little bit easier on us. So the assignment or the assessment side, this is kind of the breakdown, and there's a little bit of uncertainty because we're doing this in a mode now that we've never done before, i.e. the online mode, so we're not sure about how much progress we're going to make. But the labs will account for between 20 and 25%. And as I said before, the labs are going to be very prescriptive. So it's just a case of working your way through them. And as you now know, the labs will be concerned with rolling out that movies app. Then in terms of the remaining 75 to 80%, that'll be made up of two projects. One where you will develop a client side, and the other where you will develop a web API side. Now, we will be asked on the client side, we will be asking you to take the movies app and extend it predominantly. Only on exceptional cases can somebody develop something other than the movies fan app, and you would have to justify, but we are open to people going a different route if they wish, but you would have to justify it with us, and you would definitely have to tell us beforehand that you would like to do something else. On the web API side, similarly, you will take the movies web API that you develop with Frank and extend that out as well. I'm not sure if that answers the question or not.
Yeah.
Yeah, okay. Okay. So really, you know, I mean, I could give you a spec for the React single page app now, but you're not going to be able to do anything until we get well into the labs. That's constraint, obviously, but that's the way it is. You don't have this slide now in the set of slides that I uploaded onto Moodle, but